name is Megumi Serdan. Welcome to my presentation for Data 625, covering the Unit 6 assignment Network Graphs. Today I will be comparing the structural vulnerabilities and network security for Network 2 and Network 3. Let's begin with our Network 2. Even though both of our networks have the exact same number of employees, their security profiles are not comparable. Looking at Network 2, we see a decentralized mesh-like structure. From an operational standpoint, this network is highly robust. If one employee's device goes offline, there are multiple alternative pathways. Messages will easily reroute and reach their destination without causing a major bottleneck. However, this interconnectivity is a double-edged sword. If a node gets infected with malware, the numerous connections means it can steadily crawl through the web of users. My recommendation for Network 2 is to implement strict endpoint detection and response on every machine, allowing us to immediately quarantine infected nodes before the malware traverses the multiple pathways. Turning our attention to Network 3, we see a drastically different structure. This is a highly centralized hub-and-spoke topology. Because of this layout, Network 3 is highly fragile. It relies heavily on central gatekeepers. If a central hub's device goes down, communication grinds to a halt, completely isolating the outer spokes and departments. Conversely, if one of these central hubs get hit with malware, it acts as a super spreader, instantly distributing the virus to every single node connected to it. My primary recommendation for this client is to immediately establish a redundant secondary communication line between the outer nodes so that they don't rely entirely on the center, and to put extreme zero-trust security protocols on the hub devices. To summarize why I made the differing assessments, I relied heavily on calculating the betweenness centrality on both datasets. This metric measures how often a node acts as a vital bridge along the shortest path between the two other nodes. In the data for Network 2, the centrality scores are low and evenly distributed across the board, mathematically proving its resilience and lack of bottlenecks. However, in Network 3, the centrality is heavily skewed. A single node, named Nebula, dominates with a massive centrality score of 0.72, creating a single point of failure. Ultimately, identical employees do not equal identical risks. Network 3 requires an urgent architectural change to survive a targeted attack. Thank you for your time and hope you enjoyed this presentation.